Okay, we are looking at chapter 4, which means I'm going to Moodle to open that up here. I'm going to close that right here. Okay, courses. Do you remember me saying the other day that I am a product of Bugs Bunny? I'm thinking I'm going to type in, I can actually get to, come on, guy. All right, no, you're not working for me. Let's try this. There's a character on there that says curses foiled again. So when I'm thinking I have to type in courses, it sounded like curses, and my head went to foiled again. Do you guys ever talk about stuff that goes on your heads like that? No? Okay.
That's the issue.
Well, that's honest. Okay, we're opening up plant ecology and getting chapter 4 up and running. Back. Here we go.
There are a few of the multiple choice. Yeah.
He does that. He loves to trick you with multiple choice. That's why he calls it multiple guess.
Yeah. I mean, there's a few of them that I was iffish, like I had it down to 2 answers, but I'm like, yeah, I had like 3 and 4 that I was like, yeah. And then there's some of the longest answers I'm like, I don't think I got everything, but I think I got the most. At least some of it, you know. At least the general concept. At least to get half credit. And it was out of 134 points, which are like in it, like 100 would be 125. So he gave us like
he always does. I think for our final last semester for GIS, he had like 141 or 43 points. Or 145 points. I said that.
I got a really good score.
I had 134.
I got 100 on my ecology. Paper that we had to write.
Oh.
He was just happy.
What did you actually want? I think I did mine on the B3.
Mine was
Because I knew a lot from you before.
conservation stuff.
Yeah.
Biodiversity. Yeah, it was like biodiversity and threats or something. Which I've already written paper on. So I still have all those sources.
Mm-hmm.
Oh, I really did rewrite the paper. I just had all the sources. Good luck. It's a completely different paper.
I'm just kidding.
What was the topic?
Biodiversity.
Oh, just that.
Yeah, it was.
Of, not biodiversity of the tropics, biodiversity.
It was like threats to biodiversity. I think that's what it was.
That's what I put in as a
That's what I think.
I didn't pay on the technology plan.
Oh, yeah.
I needed that one. Oh man, I'm glad we never
Those
say that
tests
again.
are so hard.
And then like the bug collection, it was like they were scores.
I'm pretty sure all of ours are still done.
No, I took mine.
Well, the rest of them are still done.
Yeah.
I just don't have anything to put on.
I was tempted to take it so I can help my sister do some bio, and if she has a teacher, I know she'd do like a bug collection, a small mini one. And so I was gonna help her.
I can't
for
believe
my
I
bugs.
called pest.
Yeah,
Ask her for
right.
bugs.
Like, keep your bugs this way.
I was desperate. I went out the day that it was due. It was about 30 bucks.
See, my mom wanted mine for class here.
Okay, guys. I think we're ready to go. All right, so on the board, we've got our outline. Turn both of this off, it's easier to see. looking at soil composition and structure. And hey, you've had some hands-on experience in looking at that, soil texture, and then you put those and things together to evaluate composition of soils. And you should recognize that composition is going to be unique based on location, right? Next thing, soil pH, something that Luke worked up for us in lab. Soil moisture is another one. I actually have a moisture meter now. I ordered one, so when we go out in the field, we'll around our trees, we'll be able to evaluate in the field soil moisture. And I think it's got a pH unit on it as well. So we'll take a look at that in just a quick minute. We're going to look at some profiles very briefly, just to kind of give you an idea of how those differ. Remember I told you when you're driving down the highway and they've cut an escarpment off, you're seeing a profile. That's the soil's profile to quite a depth, depending on how far they had to cut in order to engineer the highway. Soil orders, table 4.1, we'll take a look at. Organic matter, that's something we're working on. I got my metal crucible so we can switch our soils out into the metal crucible and work those. Water movement through the soil, nutrition, and nutrient use efficiency. So getting us started, terms and definitions, remember that you need to be familiar with bold print terms and be able to use them as you give me back a short answer using appropriate terms and in context. So soil composition and structure, looking at size classes, boulder to clay. One of the things I told you guys when we were saving those little vials after we sent it through the texture separator, the shaker thing that you guys worked on, we saw different size of soil particles. And you can range this from boulders, really large sizes, to clay particles, really small sizes. So there's a nice little diagram in there that can give you some idea of, let's see if I can make this bigger. Nope, not working. Nope, okay. So hopefully you can do this. Let's see if I can do it without that thing running. Gives you a measurement thing here. Here we go. It works here. Larger. And you can see it ranging on this diagram from fine gravel to coarse sand, medium sand, fine sand. Remember how we had those categories that we were looking at in the cone texture thing that Courtney was working, those little vials that she did with the solutions. When we looked at the categories and we put the results up on the board, those are the categories that we were using. There are increments of coarse size associated with those. Ranges where you have breakpoints of what those sizes are. And it goes all the way from fine gravel literally up to boulders. Boulders are the biggest units that we can have out there, and then all the way down to clay, silt and clay, and those are the smallest components that we have out there. So that just shows you that there's a broad distribution of categories that we can see when we characterize soil. It's all about characterization, right? Because you may have, here you are in Georgia, you're going to have lots of silt and clay. Florida, nothing but sand. Sand, 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 but different sizes of sand, coarse, medium, and fine-grained sand, okay? Other places, you're going to have different components. You're going to have different components not only based on the texture of soil particles, but also its organic content is going to differ as well. So looking at this table here for texture classes and major factors here, texture is defined as the relative portion of different sized particles, right? And when we sifted our soil sample and got those categories, that's our texture. That's our soil texture. When we put that picture together, certain percent sand, certain percent silt, certain percent clay, that's the texture of our soil. Classes come out when we look at this kind of diagram here, our pyramid diagram. It's based on combinations of three components. Agriculturalists use these because they are the three most important compositions of soil that tells us how agricultural crops will do. So this is like a major thing that came out of agronomy, came out of the extension offices. So you go out and you take a soil sample and you want to know sand, silt, and clay. That tells us about possible nutrient composition, because remember I talked about how the smaller the particle is, the more it hangs on to water and nutrients suspended in the water. If all you have is sand, those are really big particles. It's not going to, got lots of air spaces, but not a whole lot of nutrients are staying up in the soil column. So we've got these classes here. But let's take first a look at some of these composition. It's a major factor in determining plant growth and survival. We've got the 2 bar here. Grab this, make it bigger. Here. So when we have, here's some categories for you. Looking again at sand, silt, and clay. These are the axes on the triad here. We're going to take a look at that in just a second. But if you see sand is the yellow, silt is the orange, and clay is the red, 92% sand makes that soil texture sandy. Big surprise, okay? But then when you've got 85 and you increase your silt component, it's loamy sand, okay? You've got a little bit more of a different composition value there. And then you've got 45 to 40 to 35, then you drop the sand because it's dropped down below, and you've got kind of an even partition there. It becomes loam. Loam is a really good composition. Sand in this texture allows for spaces between the particles, and therefore air is in the sand, in the soil. Air is necessary for cellular respiration. So that size grain allows for air spaces in the mixture of the sand. If you have the silt and clay, you've got the smaller particles that also allow that soil mixture to hold on to water high up in the column. If it's just sand, it's gonna percolate right on down through. But if you've got that nice clay and silt mixture, it's gonna hang on to water, and the water is going to have suspended minerals, nitrogen, phosphorus, potassium, suspended in the water. And when the root mass is spreading through that loam composition, it's got a nice environment, right? The root has oxygen to do cellular respiration. It has water up near the root mass, up in the soil column, and it has nutrients that are suspended in there as well. So that sand, silt, clay combination or loam is a really important one. And if you start to have a little bit more silt, less sand and clay, then we're going from sandy, loamy sand to silt loam. See how your partitions are just kind of shifting a little bit. And then, let me get this guy out of the way. Clay loam and clay is when we see proportionally more clay than silt. Clay loam is when we have kind of an even partition between all three. But how did we arrive at this? These are percents composition by dry weights of the soils. We can take a look at this diagram right here. Let's open that one up. Take a look at it. So if you look here, along one axis we have sand content and percent. We did this. We took a soil sample, we sent it down through our shaker and separated it out, and then we knew what the initial overall weight was. So if we had some sand sorted out as that percent of original. Remember, we did the calculation on the board. Sand out of the total composition of the texture of that soil. Silt out of the total composition of texture out of that soil. Once you figure that out, did anybody write down or take a picture of that? What was our percentage? What were our percentages for the soil that we did? Let's see if we can work this out on our diagram. Write it on the board here. Just looking at sand, silt, and clay.